Okay, rationalize the denominator. So we're still in 5.4. So rationalizing the denominator means if we have a fraction and we have a square root in the bottom, we rationalize the denominator, and that means remove any square root signs from the denominator, the bottom of the fraction. So a long time ago, hundreds of years ago, they made this rule that said if your answer has a radical sign in the denominator, in the bottom of the fraction, it's not good. Remove it. Okay? And so we just have to follow the rule. So I'm going to show you how to do it. Ready? So rationalize the denominator. So whatever number is under the square root, the radicand, what we're going to do is we're going to multiply it by the same number in the top and the bottom. Let me write it so you can read it better. Why do we do that? What's 2 over 2? 1. What's 5 over 5? 1. What's 1,000 over 1,000? 1. What's happy face over happy face? 1. What's root 5 over root 5 equal to? 1. So really I'm multiplying this by 1, but it doesn't really look like 1. So I'm not changing this, the value of it, but I'm changing what it looks like. Okay, so whatever number is under the radical here, I use this and I multiply it same over same. Okay, so remember, multiplying fractions, we multiply the bottoms and the tops. So let's do the top. This is going to be 3 times root 5, and this is going to be root 5 times root 5. Now remember the rule that if we have multiply, we can put them, multiplying radicals, we can put these together. So this is really 5 times 5 under the radical, which is really root 25. Oops, you can't see that well. That's root 25. And what's the square root of 25? 5. So we have a 5 on the bottom. Now 3 times root 5, that's not a radical, so we can't put them under the sign together. So he just stays as a coefficient in the front, in front of the 5. So 3 root 5, 3 root 5. So now we have an answer that does not have a radical in the bottom, which means we've rationalized the denominator. So let's use your calculator to check. Now our calculators know this rule. They say, oh, we should not have a radical in the bottom when we have a fraction, so let's check. Root 5, what does the calculator say? Yep, we did it correctly. Check. All right, let's check this one. So this has a root 7 in the bottom, so I'm going to multiply it by root 7 over root 7, same. That's really 1. So I'm not really changing, I'm not changing the value. So I multiply the bottoms and I multiply the tops. So this is 3 times root 7 times root 7. So let's look at the bottom. Remember the rule, it says when I have 2 radicals and I multiply them together, I can put them under the same radical sign. Well, that's root 49. 7 times 7 is 49. So that's just 7. The top, 3 times root 7, and I can't change it. It's just 3 times root 7. Okay, so let's check. There's a radical sign in the bottom. Now there's no radical sign in the bottom. That's good. Let's check on our calculator. Always check. Make sure you are correct, because we can do silly things. Look, it's the same. So put a check mark. You are correct. Let's look at the next one. Okay, so there's a root 10 in the bottom, so I'm going to multiply this by root 10, same. So it's really root 10 times root 10, which is equal to root 100. I'm just going to write it over here. 10 times 10 is 100, so this is 10 on the bottom. And then the top, root 8 times root 10, so that's root 8 times root 10. And because they're both radicals, I can stick them together underneath one big radical sign. That's the rule. That's root 80. Now let's check. Let's see if we're done. root 8, oops, I forgot my fraction sign, root 8 over root 10. Not the same. So remember, sometimes it's not that you're wrong. I'm going to write the answer here. It's that maybe we're not finished. So 80 is kind of big. Let's see if we can simplify root 80. Yes, 4 root 5 over 10. But look, I have the root 5, but I don't have the 2 and 5. But this is like a fraction here. So maybe I can use my fraction button and simplify this. So 4 over 10, let's use our fraction button. 4 over 10, does it become more simple? Yes, 2 over 5. So that's 2 over 5 with this radical root 5 there. Now we have the correct answer. So it's not that we were wrong, it's that we just weren't finished yet. We have to finish the question and make it more simple. It's a correct answer, but it's not the most simple answer. Okay? So let's do this one. There's a root 3 in the bottom, so I'm going to multiply it by root 3 over root 3. So the bottom is root 3 times root 3, and the top, the numerator, is root 2 times root 3. Now because they're radicals on the bottom, I could put them underneath one big radical because it's a multiply. And the same for the top. They're both radicals and it's multiply, so I can put them together under one big radical sign. So that's really root 6 over root 9. Can we simplify root 6? Let's check. Nope. 3 times 3 is 9. So that simplifies to 3. Now let's check let's check to see if we are correct, or let's check to see if we're finished. So root 2 over root 3. Got the correct answer. So we're finished and it's good. Okay, next one. So see how we have coefficients, numbers in front of the radical signs? We don't really care about that when we're rationalizing the denominator. We just look and we say, oh, we have a root 3 in the denominator. We have to get rid of it. So I'm going to multiply this by root 3 over root 3. Okay. So I'll sharpen my pencil. So now we just multiply our denominators, multiply our numerators. So this is 5 root 3 times root 3, and this is 6 times root 2 times root 3. So because these are two radicals and they're separated by a multiply, we can put them together underneath one big radical sign. And the 6, the coefficient, stays in the front. And the same for these. We can put them together underneath the same radical sign. I'm just going to go over here. So this is 6, that's going to be root 6, and that's 5 root 9. Oh, that's a perfect square. 3 times 3 is 9, so we can simplify it more. That's really 3, so 5 times 3, so that's 6 root 6 over 15. So now let's check to see if we're correct or finished. So we have 6 root 2 over 5 root 3. No. Oh, we forgot. Remember? Look, this is a fraction. We have the root 6, but the fraction is not simple. We need to make this more simple. So we're going to have to remember to always check our fraction in front, the coefficient in front of the radical, these here, and see if we can make it more simple and simplify it. 2 over 5. So that's 2 over 5 with that root 6 here. And I forget what my question, what it was. Let's put it in again to check. 6 root 2 over 5 root 3. 2 root 6 over 5. Yes, we are correct. Good. So it's really important to check your answer to see if you've simplified it enough. Okay? Last question. So here we have this radical in the bottom. We're not supposed to have radicals in the bottom when we have an answer. So we're going to rationalize the denominator. That means to get rid of it, to get rid of the radical. So we take this number and we go same over same, because that's the same as 1. So now I'm going to multiply all the numerators together and the denominators together. So that's 5 root 3 times root 7. And that's 2 root 7 times root 7. And because these are two radicals here, let's not look at the 5, we can put them, and it's multiply, we can put them under the same big radical sign. And that coefficient goes in the front, that 5. Same for this, the 2 goes here, and these are multiply, and they're both radicals, so we can put them under the same radical sign. So that's 5 root 21, and that's 2 root 49. And 7 times 7 is 49. And so that's really just 2 times 7, because that's 7 times 7 is 49. So that's really 5 root 21 over 14. So let's check. Let's first, before we check our answer, I don't think we can simplify this because this is a prime number, and so you can't simplify it when you have a prime number, but let's just check. No. Okay, so now let's check and see if we've done it correctly. 5 root 3 over 2 root 7. Yes. Okay, so rationalizing the denominator means get rid of the radical in the bottom of a fraction. Why do we do that? Because it's the rule. The rule says you shouldn't have a radical in the bottom of a fraction when you have a final answer. So you have to practice rationalizing the denominator. Okay.